Tomorrow will be better. A truck of mass 20,000 kilograms moving at 30 meters per second applies a braking force of 120,000 newtons. How further does it move before coming to a stop? Dear friends, how further means the distance. In other words, they are asking for the braking distance. Follow me, dear friends. Solution. Now, in this kind of situations, look for an equation which you can use and which has as fewer quantities as possible. For example, consider v square equals u square plus 2as. This equation only requires us to have final and initial velocity, not leaving out the acceleration, and the distance which we are looking for. Had it been we used an equation that has time, it will give us more work because we don't have time stated in the question. All right, so this is what we're going to use, taking into account that the moment this car eventually stops, the final velocity becomes 0. Now we have been given the initial velocity. We do not have the acceleration clearly stated, but we can use Newton's second law to obtain the acceleration, which in essence is the deceleration. And last but not the least, we are having to look for the braking distance. So the first thing here, in order to use this formula, is to start by calculating this particular quantity here. Now, like I said before, we will use Newton's second law, according to which the braking force is actually the mass times the acceleration or the deceleration in this case. From this equation, it implies that the deceleration is going to be equal to the braking force divided by the mass. Numerically, we will have 120,000 Newton divided by the mass 20,000 kilograms. And if you currently punch this on your calculators, you will have that this deceleration is going to be equal to 6 meters per second square. At this point, it still has a positive sign, but our knowledge of the nature of this quantity is very important. We know that it's a deceleration, and as a result, it's going to take a negative sign while applying it in this formula because it's a negative acceleration. All right, so this means that from this equation here, v square equals to u square plus 2as, if we make if we make s the subject of this formula, we will have that s is going to be equal to, now this is 0. Oh, now let me consider it without a 0. V square minus u square all divided by 2 times a. Now we know already that v equals to 0 because it comes to a stop eventually. We already have this. Now let's apply numerically. This means we have the braking distance to be equal to negative of 30 meters per second all square divided by 2 times what we just found, which is again a deceleration. So we will put a negative because it's a deceleration, dear friends. It's very crucial because if you fail to put this, your answer might be erroneous in terms of signs. Okay, so if you correctly punch this on your calculator, then you will have that s will be equal to 75 meters and not negative 75. Tomorrow will be better.